Hey guys, this is the second video on inequalities, and on this one, we're going to be focusing on solving rational inequalities. Let's go. Hey guys, and welcome back. This is Franck, and today we are talking about how to solve rational inequalities. So if you have not done so already, go ahead and subscribe to the channel so you can get more videos like this one. So, without further ado, I'm going to be solving these inequalities in 4 steps. The first one is going to be to move everything on one side of the inequality. Then I'm going to have to simplify the rational expression. Next, I'm going to find the zeros of the numerator and denominator. And then finally, I'm going to have my number line. So everything here should look similar to note 43, with the exception that we have to simplify our rational expression so we can set the numerator and denominator equal to 0. And so let's go ahead and start with the first one. My first example here is going to be x minus 4 divided by x plus 3 bigger than 0. And of course here everything is already moved on one side and everything is already simplified. So all I have to do here is find the zeros of the numerator and denominator. That's going to be for the numerator x equals 4 with multiplicity 1, and for the denominator x equals negative 3 with multiplicity 1. Or should I say x not equal to negative 3 with multiplicity 1. Because remember, numbers that make the denominator zeros are bad numbers. You don't want them anywhere near your graph or your solutions. Next, let's draw a number line here. And then after I draw this number line, I'm going to put my points in. I'm going to put negative 3 here, and then I'm going to put 4. Notice that I put a double line at negative 3 here. That's just to remind myself that negative 3 is actually a bad point. It's where the vertical asymptote should be. And so I'm not going to include this particular point in my solution whatsoever. Whether I have a strictly inequality sign or an inequality sign with an equal sign next to it, I'm not going to include this point in my solution. And so now let's go ahead and pick a point and test that point. I'm going to go ahead and pick 0 here. And so if I plug in 0 into my inequality, I'm going to have on top negative 4 and on the bottom 3. So that means that my answer here is negative. So I'm going to put a negative sign between negative 3 and 4. And so since they both have multiplicity 1, as I cross them, I should change the sign. And so the sign after I cross negative 3 here should be positive, and the sign after I cross 4 here should be positive as well. And so since I'm looking for the positive side of this number line, my solutions are going to be from negative infinity to negative 3, open parentheses on both, and then from 4 to infinity, open parentheses on both as well, because of the strictly bigger than sign, I do not want to include 4. All right, so let me give you a second example here. I'm going to have x plus 3 in parentheses multiplied by x minus 2 in parentheses divided by x plus 1. And that's going to be less than or equal to 0. Okay, and so my first step is already done because everything is already moved on one side. And then my second step also is done because everything is already simplified here. Then I'm going to have to find the zeros of the numerator and the denominator. For the numerator here, I know that x should be equal to negative 3 or 2. And on the denominator, I know that x should not be equal to negative 1. And of course, all of these zeros happen to have multiplicity 1. So that means that the sign is going to change as you go through each of them. So on my number line here, I'm going to put negative 3, negative 1, and 2. Of course, with a double line here at negative 1 to tell myself that that's a bad point. It's the vertical asymptote. And I'm going to test a point. So I'm going to pick 0 as usual because that's the easiest point you can pick, given that it's available. And so if I go ahead and plug 0 into my rational expression, I'm going to get 3 times negative 2 divided by 1. That's going to give me negative 6. That happens to be negative. So I'm going to go ahead and put a negative sign between negative 1 and 2 here. And so if I go through negative 1, my sign will change to positive. And if I go through negative 3, my sign will revert back to negative. And as I go through 2 here, my sign should change to positive. And so since I'm looking for the portions of my number line where the rational expression happens to be less than or equal to 0, that's going to be from negative infinity all the way to negative 3. Open at infinity here, but close at negative 3 because of the equal sign. And I'm going to have also from negative 1 to 2. Of course, I'm going to close at 2 here because of the equality sign, but I'm going to open at negative 1 here because negative 1 happens to be out of the domain for my rational expression. And so with that, we are done here. All right, so let me give you a third example here. I'm going to have x divided by x minus 1 bigger than 2. And so my first step here should be to move everything on one side. So I'm going to have x divided by x minus 1 minus 2 bigger than 0. And of course, I'm going to have to simplify this. So I'm going to have here x times 1 is x. Then I'm going to multiply the x minus 1 by the negative 2. That's going to give me negative 2x plus 2. And then divide everything by x minus 1, basically making it have the same denominator. With that, the numerator is going to be negative x plus 2, while the bottom here is going to be x minus 1, bigger than 0, of course. And we are done with the simplification. Now we can go ahead and find the zeros of the numerator and denominator. So for the numerator here, I'm going to have x equal to 2. And for the denominator, x should not be equal to 1, with each of those having multiplicity 1. For my number line here, I'm going to put 1 and 2 with a double line at 1. And I'm going to go ahead and test 0 as usual. So if I plug in 0 into my inequality, I'm going to get negative 0 plus 2. That's going to give me 2 divided by negative 1, which happens to be negative. So I'm going to go ahead and put a negative sign here between negative infinity and 1. And of course, going through 1 here, the sign is going to change to positive. And then going through 2, it will revert back to negative. Since I'm looking for the positive portion of this number line, my solution is simply going to be from 1 to 2. Both of those endpoints open. All right, so let me give you one last example. My last example here is going to be x squared minus x minus 2 divided by x squared minus 4x plus 3 bigger than or equal to 0. Of course, everything is already moved on one side, so all I have to do here is simplify this. And if I want to simplify this, I need to factor both numerator and denominator to see if things can cancel out. And therefore, I'm looking for two numbers here on the top that are adding up to negative 1 and multiplying to negative 2. Those are going to be negative 2 and 1. So I'm going to have here x minus 2 and x plus 1. On the bottom, I'm looking for two numbers that are adding up to negative 4 and multiplying to 3. That's going to be negative 3 and negative 1. And so I'm going to have here x minus 3 and x minus 1. And as you can see here, nothing cancels, so we're already all simplified. I'm going to go ahead and then find the zeros of the numerator and denominator. For the top here, I'm going to have x equals to 2 or negative 1. And on the bottom, I'm going to have x not equal to 3 or 1. I'm going to go ahead and put them all on my number line here. I'm going to have negative 1, 1 with double line, 2, and 3 with double line. Of course, you already know it. I'm going to go ahead and test 0. So if I plug in 0 into my rational expression here, I'm going to get on top here 0 squared minus 0 minus 2. That's going to be negative 2. And on the bottom, 0 squared minus 4 times 0 plus 3. That's going to give me 3. And of course, that happens to be a negative number. So I'm going to put a negative sign between negative 1 and 1 here. And of course, as I go through negative 1, my sign will change to positive. And as I go through 1, my sign should also change to positive. Through 2, it would revert back to negative. And then through 3, it should change back to positive. And since I'm looking for the positive portions of my number line, including the endpoints because of the equal sign, my solution is simply going to be going from negative infinity to negative 1. Of course, open at infinity because always, and close at negative 1 because of the equal sign. And then I'm going to have from 1 to 2. And that's going to be open at 1 because of the denominator, and closed at 2 because of the equality. And finally, I'm also going to have from 3 to infinity. And that's going to be open at 3 because of the denominator, and open at infinity because you always do open infinity. And so with that, we are done. If you would like a copy of this particular note, check out the descriptions below. Don't forget to subscribe, and if you like the way I break down the material, give me a thumbs up, and I'll see you next time. Bye-bye.